Welcome back to LokadTV. William Edwards Deming once famously said that without data, you're just another person with an opinion. Despite this, many companies fail to consider exactly how and where their data is stored, instead placing a high amount of importance on expensive business intelligence tools. Today on LokadTV, we're going to discuss a little bit more about the concept of data lakes and understand why those companies should be taking more interest in them. So Johannes, as always, perhaps we should just start by defining a little bit more about what data lakes are and where they've come from.
Okay, so first, what data lakes are. A data lake is typically another kind of database with some particularities, which is intended to consolidate pretty much all the core data of your company, especially all the transactional data, like what you've sold, what you've purchased, your stock levels, and whatnot. So that's the intent. In terms of end usage of the data lake, the idea is that it's intended not for humans, but for apps. So the idea is that you put a data lake not so that people can actually look at the data like they would do with, let's say, BI, but it's more like you have a data lake where everything has been consolidated so that you can have, let's say, a domain-specific app that is very data-driven that will be able to pull pretty much tons of data, if not all the data from the data lake, crunch it and generate, smart decisions for marketing, supply chains, human resources, or whatnot. So fundamentally, it's like an area where a place where you can consolidate all the data to serve the data in batch to smart apps. Then for the second part of your question is where does that come from? Well, there is a long history that is kind of dating back to the idea of data warehousings and data marts.
Okay, and data warehouses was sort of a trend that we saw probably over 20 years ago now. So what's changed between then and now, and what's the key differences?
That's interesting. The buzzword, let's say, data lake had 20 years ago, it was indeed data warehouse. And it's interesting because we had the pair of, at present time, we have data lake and data scientist. And 20 years ago, it was data warehouse and data mining, which is basically the same, the evolution of the same ideas, but just revisited 20 years later. So what has changed? I mean, as far data lakes are concerned, quite a few things. First, the technology of those data lakes has changed so that those data lakes are much more efficient to serve and to store and serve large amount of data. And then on top of that, we had cloud computing in the middle, which means that nowadays you can have data lakes that are completely on demand, where it's pay as you go per terabyte, which is also something quite different compared to 20 years ago. 20 years ago, if you wanted to have like a data warehouse, you would have to buy a very expensive, probably appliance from, let's say, Oracle, to put all your data in that. But then you're stuck with the appliance that you just acquired. Nowadays, with cloud computing platforms, it means that you can have pay as you go per terabyte. So, and it's also extremely aggressive in terms of pricing, so that if you decide that finally it's not exactly the way you want to do it, you can just delete the resource on the cloud and start again.
Okay, so that's sort of the technical sort of side of things. How about the philosophy? I mean, what's changed in the mindset, and what's changed in how we're using data lakes compared to those warehouses?
Yes, again, there was indeed quite an evolution. I mean, as the problem with data warehouses as they were thought, 20 years ago, is that it put, I would say, a lot of pressure on IT to properly organize the data. Actually, you even had a data warehouse that was supposed to be organized in data marts, with one data mart intended for every kind of division. So you would have the marketing data mart, the supply chain data mart, the finance data mart, etc. And the data mart were like subset, if you want, or subsystems within your data warehouse. And the problems that we had with this approach, which was kind of similar I would say, in spirit to what was done for business intelligence, is that there was a high degree of expectations on the fact that data would be already kind of prepared, organized, with where you've reattached, customers to sales, to returns. You kind of glue things together, all the things that are going together. And it's a lot of efforts actually to, technically it's about joining tables. It's to connect all those tables together with proper joins, etc. So 20 years ago, the philosophy was to do kind of a lot, and it was so that it would be quite similar to what was being done on BI, and quite similar to what was done naturally for relational systems. The problems of this approach was that the amount of work it requires is completely enormous, and so you end up with typically IT divisions that were just completely overwhelmed by the sheer amount of requirements that was falling on them because of this data warehouse project. So as a result, frequently it was failing because, well, just IT failed to deliver it.
But what about today? I mean, surely things are going to get a little bit messy now. You've got these data lakes.
So data lakes, in terms of philosophy, are much leaner because the philosophy is, well, data lake is just a recipient for a clean extraction, but a clean dump extractions of all the data that lies into other systems. So you do not try to do any fancy recombination of both the data that comes from the CRM plus the data that comes from the ERP plus the data that comes from your web platform. You're just going to extract those data sources and dump them into the data lake. And the data lake is well behaved thanks to the technology, meaning that you can dump a huge amount of data. It will bear the load without complaining. I mean, if you're on the cloud, you will be charged for it.
How do you know that the data that you're actually using is good data? I mean, how are you keeping track of which data is up to date? I mean, if you're just dumping it all in this lake, you can never keep track.
So that's a trick. I mean, the responsibility of IT with the data lake is to make sure that the data lake contains an accurate reflection of what is in the original systems, but that do not require any understanding of what's going on business-wise. You just I have a CRM. The CRM has 200 tables, relational tables. I just mirror them into the data lake, and this is it. I don't need to understand whatever is happening in the CRM. So who needs, but that begs the question, who needs to understand what is going on within the CRM? Well, it turned out that it's the divisions themselves who want to exploit the data. And the problem is, in reality, is that it's highly problem specific, the interpretation of the data. So for example, the way you look at the sales data is different whether you want to solve a marketing problem or supply chain problem. So that's why, and that was also one of the problems why those, I would say 20 years ago, many of those data warehousing initiatives failed, is because the vision was we are going to produce like a unified model of the owner company, but then it turned out that it was highly frustrating for every division because marketing said, oh, it doesn't exactly fit the vision that I have of my domain, and the supply chain would say the same, and finance would say the same. So in contrast, the idea is that now it's more like the divisions themselves, so the supply chain, marketing, finance, human resources, and whatnot, who are going to be the primary stakeholders into making sense of the data. And the good news is, if, for example, you are, let's say, the sales division, well, and you are interested in the data that comes from the CRM. Well, it turned out that most of the data that is in the CRM was generated by your own actions. So it just happened that because you're the sales team, you know a lot better than basically the rest of the company what is in the CRM, because It's your own entry processes that define what is in the CRM in the first place.
So if those data warehouses failed sort of 20 years ago, what's changed now? What's changed in the world of technology that means they're not going to fail today?
I mean, again, there is tons of things that change. A particular challenge is, especially in supply chain, is that we are pretty much by design dealing with distributed systems. What do I mean distributed? I mean not everything in one place. Because by definitions, you know, if you have like multiple warehouses, well, they are not in the same place. Your suppliers are not in the same place than your warehouse. Your clients are not, etc. So it's by definitions, we are looking at systems that are, you know, dispersed. And you want to consolidate all of those data in one place, which is your data lake, which technically needs to happen over the network. So obviously 20 years ago, internet was already invented. It did exist. But nonetheless, the quality of the tools to move data around across the internet was completely different compared to what we have today. And then the quality of the network itself was also completely different. I mean, nowadays, if you want to move, you know, your, let's say, not a large company, you know, a 1,000 employee company, so you're sizable, but you're not like a mega corp. 20 years ago, if you wanted to move 1 gigabyte of data per day across the internet, it was complicated. I mean, you needed to have like access to the fiber. For example, in Paris, there was like only one place in Paris 20 years ago where you could have access to the fibers. That was the area near the stock exchange, which is the Quartier de la Bourse, but whatever. So there was like 1 square kilometer where you could easily get access to the fiber. Anywhere else, well, you had to lay down your own fiber if you wanted it. So megacorp, you could do that. Even a sizable business, you know, 1,000 employees, could not. This has changed. I mean, this sort of things now is very straightforward. So the tooling is better. You can move around literally gigabytes without, you know, too much fuss. And the fact that you have, you know, on-demand systems, you know, those data lakes are not only, you know, very cheap thanks to, you know, the economies of scale of those cloud computing platforms. The fact that they are on demand mean that also you can do, you know, trial and error. If you just try to set up a data lake, it's a complete failure. You know, you did it right, you did it wrong, and well, you can just say delete, retry, and you're just paying for what you use. So it's so you can iterate rapidly. It's not like, again, 20 years ago, you had to commit yourself from buying a very expensive appliance. If you get it wrong, that was a big problem.
Okay, and I bet those finance areas probably still have the quickest internet at the minute. What would you sort of say to a big multinational company that has already got a good grip of their data? They're already understanding things using business intelligence tools. I mean, why should they be interested in a data lake?
The problem with business intelligence is that fundamentally it's intended for humans. It's good, but it means that every single, you know, minute that people are going to look at those numbers, it's a minute where you are actually paying an employee to have a look at numbers instead of, you know, doing something. So you can very easily produce, you know, millions of numbers, which will require thousands of hours of man hours to be processed, which is extremely, extremely expensive. So the problem is that, I mean, business intelligence, the way I see it, is a type of technology that is fairly dated. I mean, it was a way to get first, I would say, a class of basic analysis of your data in a way that was kind of relatively real time. So it was very interesting because if we go back 30 years ago, you know, which was, you know, the time where business objects were started, they were created in 1990, founded, and this company was pretty much the company that popularized business intelligence. If we go back 30 years ago, companies had already databases, but if you were a retail network and you wanted to have your sales per day, per store, per product, Well, you had no options, but basically to kind of have one gigantic batch that would crunch the data over the entire weekend to produce this analysis. So, and otherwise you just couldn't know you could not perform a SQL queries that would give you this information where how many units have sold, you know, per day, per product, per store. That was not possible. With business intelligence, suddenly it was possible to have this cube. You can even have hypercubes, and even better, you can have it real time. Very, very nice. But then in the end, you're just looking at a super basic aggregation of your data. And this aggregation is not a decision. It doesn't tell you if you should raise or lower your price. It doesn't tell you if you should produce more or less. It doesn't tell you if out of a production batch of 1,000 units, you should put 100 units in an airplane for faster delivery. So fundamentally, it's just about, you know, getting quantitative insights. So the big difference between, you know, BI and data lake is data lake comes with the insight that it's fundamentally a cog into a bigger picture where you will, sitting in front of the data lake, you will have typically a machine learning driven app that will crunch the data served super efficiently by the data lake in order to generate decisions automatically. And those decisions, they are something that has like a physical impact on your company, and that will create tangible value in a way.
Okay, so if we agree that maybe business intelligence tools have kind of got their limitations, if it comes to an implementation of a data lake, how actually easy is that to do? Is it just a case of uploading all this data onto the cloud and then you're away?
I mean, the complexity of implementing a data lake is strictly proportional to the complexity to access your data sources. You know, literally accessing them, not doing anything smart with them. So that means, and for large multinational, well, that means that if you have every single, you know, country in your company has its own system, well, guess what? You will have as many pipes to lay down so that you can bring the data from every single country to the data lake. But I mean, it's unfortunately you have no alternative, because the only alternative is like to have like ad hoc integration with the countries directly, and that's even more costly, because if you have two divisions, let's say marketing and supply chain, who want to access the sales data, that will be, you will pay for this integration twice. So the idea with data lake is that, well, you do it once and then it's in the data lake, which make it very suitable for the rest of the company to access the data. So the complexity is completely dependent on what you have. But also, again, if we go back to your initial quote, if you don't have data, you're just a man with an opinion. Well, you don't have any alternative to retrieve this data anywhere if you want to do any kind of measurements.
Let's sort of bring things together now. If there's so many positives to data lakes, and it seems fairly simplistic, it's just a large receptacle of data at the end of the day, why is it something that's not being so readily adopted by industry at the minute?
So it turned out that the very, very smart tech-driven companies did adopt data lakes quite a while ago, and they even went beyond that with, I would say, the APIification of their company, meaning that you're going to put an API, application programming interface, on every subsystem, which is like the next step that happens after the data lake. So I would say smart e-commerce, for example, they have already consolidated their data, and that allows them to do all sort of, I would say, cross-functional optimization, where you need to have a look at both the data that comes from the website, what you pay for search engine merchandise marketing, you know, the Google AdWords and whatnot, and cross all this data by to do smart, I would say, to take smart decisions in terms of direct marketing action and whatnot. In terms of, I would say, pure tech-driven companies like the Microsoft or the Google of this world, they have also been doing similar things, you know, for literally for decades. I mean, Google has only been around for 2 decades, but other companies like other tech companies have been doing that for quite a while now.
Okay, so if they've been doing that for decades, how about the future? What's next? Are we going to be taking a dip in a data ocean sometime soon, or what?
Yes, I mean, what I can see next is that companies that operate supply chains, now that those data lakes have become, I would say, very, very accessible, you know, very cheap. Those data lakes are going to be implemented. I mean, we see among our customers that a lot of customers that didn't have, you know, a data lake 1 year ago now have a data lake actually on the, I would say, the tech aggressive side. So there was like probably a turn point in the last 2 years on those data lakes matters. So I suspect that most large companies will, within the next probably 5 years, will have implemented their own data lakes. Because otherwise they would just be completely outcompeted by other large companies who will have done that for them. But then in terms of, there are also limits, you know. In particular, a data lake is just like a read-only copy of all the data that is like lying in other subsystems. That's why I was saying that there is a next step is to have all the subsystems that expose APIs, application programming interfaces, because that's typically what Amazon has done historically. Because those APIs, they let you even do more. Suddenly you're not just read only, you can also act. So the idea is that not only you can consolidate all the data, read, crunch, take, you know, all those decisions, and then what do you do with those decisions that have been computed? The answer is that you can send the Excel spreadsheet to the right division so that they implement your decisions, such as, well, purchase that. But if you have an API, you can directly call this API to just inject into the ERP the purchase order for this product of this quantity from this supplier, with this transport being specified and whatnot. So you can actually, if you have APIs, you can have like an end-to-end automations where you not only you generate the decision automatically, but then you implement physically these decisions automatically because it's re-injected into one of the system.
Okay, well, we're going to have to leave it there, but thanks for your time today. So that's everything for this week. Thanks very much for tuning in, and we'll be back again next time. Bye for now.